Today we're going to be learning how to convert between metric units, and we're going to be doing that using a different approach than what you have learned in class. The very first thing that you would have to do is to learn the common metric unit prefixes. There's no way around that. You have to learn them. So with that said, let's go ahead and get started. These are some of the common prefixes that you will most likely have to memorize. And you can memorize them by using a sentence. And that sentence is the following. The great monarch King Henry died unusually by drinking chocolate milk Monday night peacefully. Again, the sentence is, the great monarch King Henry died unusually by drinking chocolate milk Monday night peacefully. If you remember that sentence, you could remember the prefixes fairly easily. Something to note is that to the right side of the base unit, you're going to have negative numbers, and to the left side of the base units, you're going to have positive numbers, and I'm talking about the exponents, right? And you will notice that the exponent changes first by 1. So here you have positive 1, then positive 2, positive 3, and same thing on this side, negative 1, negative 2, negative 3. But once you reach negative 3 and positive 3, you're going to be increasing the exponent by a factor of 3. So negative 3, then negative 6, negative 9, negative 12 on the right hand side, and on the left hand side, positive 3, positive 6, positive 9, and positive 12. Let's go ahead and do one example so that conversions make sense. Say that before I use a number, let's just talk about the units. Say that I'm trying to go from centimeters to nanometers. So the only thing that is changing is this prefix, right? I have to figure out how I can get rid of this prefix and come out with this other prefix. So in order to do that, the very first thing that I'm going to do is write what each prefix stands for. So this centi right here stands for 10 to the negative 2. It's right here. Okay, and this nano stands for 10 to the negative 9. So really the base is the same, right? It's a base of 10. And what we're trying to change then will be the exponent. We're trying to change the negative 2 exponent to a negative 9 exponent. So let's go ahead and then focus on the exponents. We have negative 2. And we're trying to come out with negative 9. So you can ask yourself, negative 2 plus what is going to equal negative 9? So you can figure that out simply by solving for x. So I have negative 2 over here. In order to isolate x, I will have to do the opposite. So negative 2, the opposite of that would be positive 2. And whatever I do on this side of the equation, I have to do on this side as well. So I have negative 9 right here. I just did this positive 2, so let's do that. And so if I do negative 9 plus 2, this is going to equal negative 7. Okay. The negative would mean that I will have to move the decimal to the right, and that's why I have written over here. Okay, if you end up with a negative number, that means that you have to move the decimal to the right, and then the number will just tell you how many times. So in this particular example, you're going to have to move the decimal 7 times to the right. Now, if I had came out with a positive number, then that means that I will have to move decimal to the left. But let's first go ahead and talk about what we're doing right now. So let's put here a number so that we have something to work with. Let's say 3.02. So you will do this. First, focus on the exponents, come out with the answer, and let's go ahead and do that. We have 3.02, and we said that we have to move the decimal 7 times, but to the right. So 1, 2, 3, 4, 5, 6, 7. This will be my final answer. 3, 0, 2, 0, 0, 0, 0, 0. Now, if they ask you to write your final answer using scientific notation, then you have your decimal right here, and you're trying to move the decimal up to the point that you just have one number in front of the decimal, and that number can only be between 1 through 9, okay? And I go about this extensively in my other video about scientific notation, so if you need practice, go ahead and watch that. So here we have 1, 2, 3, 4, 5, 6, 7. So I just moved this decimal 7 times, and I moved it to the left, which means positive. So I have positive 7 as my exponent. My final answer then will be 3.02 times 10 to the positive 7. Okay? And then you want to make sure that you finish and start with the same number of significant figures. So over here we have 3 sig figs, and we're finishing out with 3 sig figs as well. Okay? So that's our final answer. Let's go ahead and do another example. Say that we have 0.031 kilograms, and they're asking us to convert that to milligrams. So again, we're going to focus on the exponents. We have positive 3 for kilo, and for milli, we have negative 3. So you will ask yourself, positive 3 plus what is going to give me negative 3? So again, you're going to go ahead and solve for x. Whatever I do on this side, I have to do on this side. And x is going to equal negative 6. The negative will tell me that I have to move to the right, right? Again, it's right here. If you have a negative number, it means that I'm going to have to move the decimal to the right, and then the number will tell you how many times. So I have to move it to the right 6 times. So let's do that. We have 0.031, and let's start moving it. 1, 2, 3, 4, 5, 6. So my final answer is 31000. Then if they ask you to write the answer in scientific notation, you have the decimal here, and you know that you have to move the decimal up to the point that you have just one digit in front of the decimal, and that digit cannot be 0, and it has to be between 1 through 9. So I'm right here, and I go 1, 2, 3, 4. I just move 4 times, and I move to the left, okay? And the left means positive. So my final answer then is going to be 3.1 times 10 to the positive 4. Okay. Then you want to go ahead and check the significant figures. I started out with 1, 2 sig figs, right? These 2 zeros do not count because they're to the left. And over here, I have also 2 significant figures. So then this right here is going to be my final answer. 3.1 times 10 to the positive 4 milligrams. Let's go ahead and do another example. Say that we have 14.1 milliliters, and they're asking us to come out with liters. So again, we're going to focus on the exponents. Milli is right here, so we have negative 3 plus watt is going to equal, and you have liters, which is a base unit, so 0. Then you're going to go ahead and solve for x, and your final answer is going to be positive 3, right? So you know that you have to move the decimal 3 times to the left, right? Left, positive. So let's go ahead and do that. We have 14.1 and I have to move it 3 times to the left. So 1, 2, 3. My final answer is 0.0141 liters. If they're asking you to use scientific notation, again, you will take that decimal and you move it up to the point that you have 1 digit in front of that decimal, and that digit has to be between 1 through 9. So I'm going to move it. This 0 is not between 1 through 9, so I move it again. Stop right here. I moved it twice, and I went to the right when I moved it. So that would mean negative. Okay? So my final answer then would be 1.41 times 10 to the negative 2 liters. Then you will go ahead and check your significant figures. And I have 3 significant figures here, 3 significant figures here, so we're good. Now say that they ask you to use dimensional analysis, which is also named the factor label method. All that this means is that you would have to show your work in a way that you can show the units being crossed out. So let's do that. Say that they're asking us to convert centimeters to kilometers, but that they want us to use dimensional analysis. So, when it comes to dimensional analysis, you first have to go from centimeters, then you have to get rid of centi, right, and come out with meters. Then you can now add another prefix to meters. So then you can add the kilo. Okay, so let's do that. First, we know that we're starting out with this. And whenever we're starting out with, let's just write it out. 5.01 centimeters. Then, whatever you want is going to go on the top of the fraction. All right, so again, we're in centimeters right here, and we're trying to go to meters. So that's what I want, and I'm gonna write that on the top. I want to get rid of centimeters. Whatever I'm trying to get rid of, I'm going to write at the bottom of the fraction. Then on the top, you're going to write whatever centi stands for. So whatever the prefix stands for, you're going to write it next to the base unit. Never next to the prefix, but next to the base unit. So centi stands for 10 to the negative 2. This right here will allow me to cross out my centimeters, and I will be left out with meters, which is the next step, right? What I wanted. So right now we have 5.01 times 10 to the negative 2 meters. Now that we are right here, I need to go to kilo. So again, whatever I want is going to go on the top. I want kilometers, and whatever I'm trying to cross out is going to go at the bottom. That's going to be meters. And then whatever the prefix stands for, you're going to write next to the base unit. The base unit is meters, right? So kilo stands for 10 to the positive 3. And you're going to write that again next to the base unit. Never next to the prefix. You will never write 10 to the third right next to kilo. It will have to be on the opposite side next to the base unit. So now this will allow me to cross out my meters. And when you plug this into the calculator, you're going to finish up with 5.01 times 10 to the negative 5. Okay. Then you will go ahead and check your sig figs to make sure that you are starting and finishing out with the same number of sig figs. So I have 3 sig figs right here, and I'm finishing out with 3. So this one is good to go. Now let's go ahead and double check this using the previous way that we used to solve it. So we have 5.01 centimeters, and we're trying to go to kilometers. Centi has a -2 exponent, -2. Kilo has a +3 exponent. And then you ask yourself, -2 plus what is going to equal +3? So I'm going to go ahead and solve for the x. This is going to equal +5. Plus tells me that I have to move the decimal to the left. So then I'm right here. Let me go ahead and write it here. 0, 1. And I'm going to move it to the left 5 times. 1, 2, 3, 4, 5. And the zeros, my final answer then is 0.0000501. If they ask me to write this in scientific notation, then we know that our decimal is right here, and I go 1, 2, 3, 4, 5. I moved it 5 times, and I moved it to the right, which means negative number. So my final answer is 5.01 times 10 to the -5. You're going to go ahead and check your sig figs. You have 3 to start with, and you're also finishing out with 3. So that's the final answer. And you notice how this final answer is exactly the same as what we did before. Let's do another example using dimensional analysis. Say that we have 0.0130 millimeters, and they're asking us to come out with nanometers. So I'm right here, and I'm trying to come out right here. Reminder that this is a 3-step process because you have to go through the base unit. So we have millimeters, we have to cross out the milli so that we can come out with the base unit, and then we can go ahead and add the other prefix, in this case, nano, to come out with nanometers. So we're starting out with 0.0130 millimeters. Whatever I want is going to go on the top. I want meters, right? Because I'm trying to go from millimeters to meters. So what I want goes at the top. What I'm trying to get rid of goes at the bottom. I'm trying to get rid of these millimeters because we're trying to move forward. So now I'm going to write whatever these milli stands for next to the base unit. Again, always next to the base unit. So here we have 10 to the -3. This is going to allow me to cross out millimeters and come out with meters. So right now we have 0.0130 times 10 to the -3 meters. So we are right here now, and we're trying to move on to nanometers. So what I want is going to go at the top. I want nanometers, and what I want to get rid of is going to go at the bottom. I'm trying to get rid of meters. And then I have to write what the prefix stands for next to the base unit. So nano stands for 10 to the -9. I'm going to go ahead and write this here. You're going to plug this into your calculator, and your final answer is going to be 13000. Then you're going to go ahead and check for significant figures. So you started out with 1, 2, 3 significant figures, right? And so you want to end up with 3 significant figures as well. Okay, so let's go ahead and do that. In order for us to finish out with 3 significant figures, we will have to take this number and change it to scientific notation. So we have the decimal right here, and let's move it 1, 2, 3, 4. Moved it 4 times, and I moved it 4 times to the left, which means positive number. Okay, right now I have 2 sig figs, so by adding another 0, I finish out with 3 sig figs, which is what I needed to finish out with. Now let's go ahead and use the first method to solve for the same problem. So again, we have 0.0130 millimeters, and they're asking us to go to nanometers. So we're right here, -3, and we have to come out with an exponent -9 for nano. So again, we have -3 plus what is going to equal -9. So you're just going to go ahead and again solve for x, and x equals -6. So this tells me that I have to move the decimal 6 times to the right. Okay, negative number again to the right. So here we have it, and let's do it. We have, I'm gonna go ahead and write it again here so that it's clear, and let's go ahead and move the decimal. 1, 2, 3, 4, 5, and 6. Okay, so my final answer is this. And again, I want to finish out with the same number of significant figures. Right here, I have 1, 2 sig figs, and over here, I have 1, 2, 3 significant figures. So let's go ahead and change this to 3 significant figures using scientific notation. So our decimal is here, and we're going 1, 2, 3, 4. Stop right there. 1.3 times 10. I move the decimal 4 times to the left, which means positive. And now I have 2 sig figs, and to finish up with 3 significant figures, I add another 0. And just like that, we're done. I hope that you guys found that video helpful. If you have any questions, please make sure to leave me some in the comment section. Other than that, thank you guys for watching, and I will see you in the next video. Goodbye.